Okay, for this example, write a polynomial function f of least degree that has rational coefficients, a leading coefficient of 1, and the zeros are at 4 and 1 minus root 5. So x equals 4, x equals 1 minus root 5, and so if that's true, then x has to also equal 1 plus root 5. So then we write that in factored form. So the x equals 4, that gets written as x minus 4. This gets written as x, and it's always minus, times 1 minus root 5. And then this here gets written as x minus 1 plus root 5. Then we need to regroup. So this is x minus 4. I'm going to regroup. So this is going to become x minus 1. I'm just distributing the negative. X minus 1 plus square root of 5. And then I'm going to group these together. And then distribute the negative. Distribute the negative again. So this is x minus 1. This becomes a minus root 5. And then I want these together. So remember the pattern. This is really an a minus b pattern. So this is going to be x minus 1 squared. And then this will be a root 5 squared. So let me rewrite that as x minus 4. And this becomes x minus 1 all to the squared minus root 5 to the square. So x minus 4, x minus 1 squared. So x minus 1, that's x squared minus x plus 1. So that becomes x squared minus 2x plus 1. So that's going to replace this. So I'm going to put that in. X squared minus 2x plus 1. This minus square root of 5 squared, that just becomes a negative 5, right? So we just get rid of the square. And so the square root and the square, that cancels each other out. So that's minus 5. So simplifying further, x minus 4. I can combine 1 and negative 5. So that's x squared minus 2x minus 4. Now I can use the box method, or you can use any method you're most comfortable with to multiply this through, and we're almost done. X times negative 4, x squared minus 2x minus 4. So get x cubed minus 2x squared minus 4x minus 4x squared, positive 8x, and positive 16. We can combine like terms. So we get f of x equals x cubed minus 6x squared plus 4x plus 16. So this example here, write a polynomial function g of least degree that has rational coefficients and a leading coefficient of 1. Our zeros are at 2 and 3 plus root 7. So x equals 2, x equals 3 plus root 7, and x equals 3 minus root 7. So let's write that in factored form. So it's always x minus whatever this is, right? So the whole thing is grouped together. So the first one will be x minus 2. Then this is x minus 3 plus root 7. And then this will be x minus 3 minus root 7, so conjugates. And then let's simplify. So we need to regroup. Again, we're distributing this negative inside. So x minus 3 minus root 7. This is parentheses x minus 3 plus root 7. And then this x minus 3 and x minus 3, just group those together. So those are alike now. So we can rewrite that again as x minus 3 to the square. So x minus 3, the same, squared. So it's the a minus b, a plus b pattern, which is a squared minus b squared. And then this back part is negative root 7 times root 7. That's negative root 7 squared. And that, again, that takes care of the square root and the square. It cancels each other out. So simplifying this is x minus 2. And then we have to expand the x minus 3 squared. So that's x squared minus 3x plus 9. So that will become x squared minus 6x plus 9. So that's the pink. So that'll be x squared minus 6x plus 9. And then this here just becomes a negative 7. So simplify that. We have x minus 2 times x squared minus 6x, and then a plus 2. So then we multiply that through again. X minus 2 x squared minus 6x and a positive 2. We get x cubed minus 6x squared, 2x, negative 2x squared, 12x, and negative 4. So we can combine like terms. And so our final polynomial is x cubed minus 8x squared plus 14x minus 4.